F and H are functions defined on this closed interval a to b, where a is less than b, and h is an antiderivative of f. This is also can be said, right, that the derivative of h equals f. So, which one of these following statements must be true? A says if h is less than 0, then f must be less than 0. So if h is less than 0, right, let's say a to b here. If h is less than 0, something like this is our h of x. The derivative of h of x, right, is the slope of this line. But the slope of this line is always positive because it's always greater than 0. It's always increasing. That means it's always going to be greater than 0. So a does not have to be true. H prime of x equals f of x for all real numbers h of x. That's exactly the definition of that I said here. If h is an antiderivative of f, right, you can think of it like this. The integral of f of x dx will equal h of x plus c. But if you take a derivative of h of x plus c, the constant goes away. And so you get d dx of h of x. Constant just goes away, and that is f of x. So that's going to be true. Let's just go through the rest of them just to see how they're all not true. If f is constant, then h of x equals 0. Well, if f is constant, that means h of x doesn't change. Or that means h of x is changing constantly. It's not changing how fast it changes. So if f of x is constant, let's say something like this. F of x is a constant like 1, for instance. H of x is always increasing by 1. So no, h of x does not have to be 0. It could be 0, but it doesn't have to be 0. At some point, but it's always going to be increasing or something, unless, of course, f of x is always constantly 0. And then h of x could always be 0, because the derivative of 0 is 0. So that could be the case, but it doesn't have to be the case. If f is constant, if f of c equals 0, so the derivative of h is 0 at some point, then h has a local extrema. And this typically is the case. However, there is one case that's not necessarily true, and that is if you have a saddle point. And this is h of x over the interval a to b, then we're going to get a 0 point here. This could be, let's see, it's going to be increasing, and then increasing like that. That's something like f of x would look like. So it would be 0 here, but only for that moment. It's not an extrema. Finally, if f is greater than 0 on the interval a to b, then h of c is 0 for some c. And that doesn't have to be the case, right? If f is increasing on the interval, then h is going to be at least increasing because, it's always going up. So like, if f of x is greater than 0, so f of x is something like here, that means that it's always positive, right? H will always be increasing. It could be a lot of different ways. It could be like that, or it could be, coming down really close to 0, but never hitting 0. That means h of x is always increasing. And so I could just say something like this, it doesn't have to hit 0. That's just a vertical adjustment there.